Welcome! In this video we'll be determining whether events are mutually exclusive, part 1. Let's go ahead and take a look at our first example. Determine if events A and B are mutually exclusive. Well, recall that we say two events are mutually exclusive or disjoint if and only if the probability of A intersection B is equal to 0. Now, using our general addition formula, which consists of the following, we can actually solve for this intersection. Probability of A union B is the same as the probability of A plus the probability of B minus the probability of the intersection of A and B. Now, the next step will be very simple. We just need to substitute in what we know. Notice here, we know that the probability of A union B is 43/50ths. The probability of A is 13/20ths. Plus the probability of B, which is 3/5. All of that minus the probability of A intersection B. Now what we're going to do here is to search for the least common denominator, which in this case happens to be 100. So I'm going to multiply this one by 2 over 2. This one will be multiplied by 5 over 5. And this fraction will be multiplied by 20 over 20. This will give us then 86 hundredths is equal to 65 hundredths plus 60 hundredths minus the probability of A intersection B. Now paying close attention to this one, let me bring it to this side over here. We have 86 hundredths is the same as 125 hundredths minus the probability of A intersection B. Now what I'm planning to do here is to subtract 125 hundredths from both sides so that I can eventually solve for the probability of A intersection B. So let me do that. Minus 125 hundredths on both sides of my equation. And that will imply that we have negative 39 hundredths is the same as the opposite of the probability of A intersection B. Now to get the probability by itself, let me go ahead and multiply everything by -1, or you can just divide by -1. Either way will work. And this one will imply that we have 39 hundredths is the same as the probability of A intersection B. So clearly, the probability of A intersection B is not equal to 0. Okay? Thus, A and B are not mutually exclusive. In other words, they have something, at least an outcome that they share in common. Okay? Let's see another example. Example 2. Determine if events A and B are mutually exclusive. Again, recall that two events are mutually exclusive if and only if the probability of A intersection B is equal to 0. So let's use our general addition formula. We have probability of A union B is the same as the probability of A plus the probability of B minus the probability of the intersection of A and B. Substituting in what we know the probability of A union B is 7/10. We have the following. We have 7/10 is equal to 7/20ths plus 7/20ths minus the probability of A intersection B. Now, where is this 7/20ths coming from? It's from the fact that probability of A is that value, and the second 7/20ths is coming from the fact that probability of B is equal to 7/20ths as well. Now, this one will imply that we have 7/10 is equal to 14/20ths. Since we have the same denominator, we just add the numerators, minus the probability of A intersection B. But we know that this one can be simplified by finding the greatest common factor. So really what we have is 7/10 is equal to 14 divided by 2 is 7. And 20 divided by 2 is 10. So we also have 7/10 minus the probability of A intersection B. Now what we can do here is we can actually subtract the 7/10 from both sides. So let's go ahead and do that. Let me subtract 7/10 from both sides. And that implies that we have 7/10 minus 7/10 is 0, and 7/10 minus 7/10 is also 0, minus the probability of A intersection B. In other words, we have 0 is equal to the opposite of the probability of A intersection B. Now, to solve for the probability itself, we can multiply everything by -1 or divide by -1. It doesn't matter, your choice. And you're going to get 0 is equal to the probability of A intersection B. Since that's the case, then we have two mutually exclusive events. Thus, A and B are mutually exclusive events. Okay? So, that concludes this video. Thank you very much for watching, and best of luck in your homework.